Okay, I'm back. Sorry about that. You guys there? Okay. Need to figure out why that still keeps happening. So hopefully you're looking at the exam 2 notes. Any questions on that so far, if you're looking at it? A couple people asked me, is this subnetting assignment going to be worth 10% of the grade? I'm not sure where you're seeing that. Maybe it says on an old syllabus, but it's 25%. So make sure that you watch that subnetting tutorial and that you complete the subnetting assignment and submit it first, the digital version, and it should grade it. Now, if you submit it and you get like a 97.5 or something like that, you probably did just fine. You may have just made a typo or two where my grader could not understand your answer, like you put 2 M's instead of 1 in the box. You know, I tried to be as, or you maybe didn't put anything in a text field. But if you got a high grade, don't stress so much that you got missing 1/10 of a point. If you got in the high 90s, you're probably doing most of it correctly. No, the assignment is not worth 25%. There's going to be a subnetting section on the test. The assignment is worth 5% of your grade. I believe that's what's on the syllabus. So the assignment is not part of the test, okay? There is a separate subnetting exercise on the test that you have to complete within the 3-hour time period, okay? To clarify that. Okay, you guys all seeing my shared screen? Okay. Give me a second to log in here. Don't look. Let me stop. No, I don't want to stop. Yeah. Need to log in first, so give me a minute. Excuse me. Did you guys have a good weekend? No, my weekend was terrible, as every weekend. No, don't be sorry. Just my weekends are busy. I can't tell what day it is most of the time because I work every day. But that's my choice, so don't worry about it. I appreciate that you're sorry. I need a mom. That's what I need. I need somebody to or a maid, cook and clean and do all that stuff that mom used to do. I know that sounds chauvinistic, but it's because I'm old. Okay, we're back now. Let me share the screen. Kaboom. Okay, so again, if you're not looking at exam 2 study notes, copy and paste these in to another document and answer each one of these bullet points. So let's just go over what's going to be on the test. It's only 30 multiple guess questions this time, not 40. Okay, 40 was probably too many for exam 2. because I would say that you're going to spend at least an hour of those 3 hours, if not more, on that subnetting part. In fact, when you go to take the test, when you go to take the exam, I recommend completing that part of it first. The test is presented to you all at once on one page, and I hope that's okay. So you can be doing a lot of scrolling, but do that whole subnetting thing first, then go back and answer the multiple guess questions. Okay, so I don't need to talk much about the subnetting because I've talked about it before. It's really similar, but a different thing than the assignment, mostly in content, not in structure, but in content. The scope is actually smaller. So in other words, if it took you 3 or 4 hours to do the subnetting assignment, it won't take you that long because there's only 5 entities, not 10, on the exam 2 for the subnetting, and those entities are smaller. Okay, so that's what the multi-part essay question is going to be. Same rules as before, take the test on your own. The content from chapter 6, make sure, let's just go over some important points here. I may tell you to ignore a couple things, so pay attention here. You need to know that, and this is important, in the design approach, the building block network design approach, make sure you know what the 3 steps to that are. The design, the initial design, the technology design, and then the cost assessment, the identification of needs. It's similar to the system design life cycle, except it's cyclical. Make sure that you understand that it's cyclical. Sorry, getting text from somebody who needs some help. So make sure you know what each of those steps are, and make sure you know what the goals of each of these things are. And underneath each of those 3 steps, there were 7 or 8 different things which were specific to those steps, like in the needs analysis. How do we conduct a needs analysis? One of the items, by the way, and you probably should look at these, I published up here sample RFPs that you need to study and pay attention to. Go look at those requests for proposals. That's one of the ways that we get the technology design, but that'll also help you understand the needs analysis part of it, because part of an RFP, which is published and sent to vendors, is they describe the needs. And sometimes they describe how they derived those needs. So you need to be looking, downloading, and viewing these sample RFPs and these spreadsheets that go along with them. Not that I ask specific question about any of these RFPs. I'm not going to ask you how many computers did Fort Bend want. I want you to just know what the structure of an RFP is and what are the common elements within RFP. Also, you can Google for sample RFPs. You don't have to use just these. What are the deliverables from each of these steps of the building block approach? What's involved in the technology design? What are those deliverables? How is the technology design different from the needs analysis? Define these terms. Make sure, and you can Google for these, but look in my notes first, look in the book first. Go there first when you're studying for this stuff, then go check Google. Don't Google for these things in general first. Use my notes, use the book, use the PowerPoints that are online, because that's what I'm looking for. I'm going to more defer to the answers that are derived from the content of the material that I'm sharing with you. Then you can, if you want more information on these terms, Google them and see what Google says, because most of the time it's the same or similar. Circuit loading, capacity planning, peak versus nominal network traffic, and the tools that we use to determine these things, such as MRTG or the Wi-Fi analyzer or simulation tools. What's the difference between static and dynamic network modeling tools? An example, I'll ask you, what's an example of a static network modeling tool? And one of the answers might be something like draw.io. Let me bring up a WordPad doc on the screen here. I just want to type some text down that will become part of the video. So draw.io, which we have not done that assignment yet, which is okay. We don't have to have done that assignment yet, but you should go to draw.io, become familiar with what that tool is, and read why you're using that tool, and understand that that is a static modeling tool. It's a drawing program, like a flowchart program like Visio. It is not a statistical modeling tool. Statistical modeling tools usually cost money, sometimes a lot, where they are comprised of a drawing tool like this, but they also allow you to do simulations on that model or on that map that you design, and put data through the model to see where the bottlenecks might occur. That's the hardest thing, by the way, is getting metrics from an existing network, or getting metrics and trying to figure out what you need to fix on an existing network. If you can't get metrics either on an existing network or a new network that you put in place, it becomes very difficult to measure whether it has any value or not, or whether it's doing what it's supposed to do. Just remember that you guys, that S in MIS is really dollar signs. Management information dollar signs. It's very, for most businesses, the MIS department in that function is one of the most expensive things that that company is going to do. Managing networks, managing people, managing applications, managing the data. So if you can't measure the tools that you've put in place to see whether they're doing the job until the end of the year to see whether you're making money or not, they're not very useful tools. Make sure you know what the turnpike effect is and what causes that, and how to mitigate the turnpike effect. What kind of costs do you consider during cost assessment? Let's just go through that real quick. Costs. Start telling me, guys, what costs do you consider when you're doing a cost assessment of a network? It's in the notes, but just some things that might be off the top of your head. Cost of hardware, cost of circuits. You need to consider the install cost versus the MRC. What does MRC stand for? Somebody? Either turn on your mic and tell me, or type it in the chat window. What's MRC stand for? And this is not specific to my class. You should, as business majors, you should all know what MRC stands for in terms of business and money. No idea? Say no. Say I don't know if you don't know in the chat window, so I know that some people are there other than me and Ella and Colette. Okay, thank you guys. Thanks. Stands for, you can go Google for this stuff, monthly recurring costs. Almost all services, particularly circuit services, maintenance contracts, they all have fixed monthly recurring costs, which you have to pay whether or not your company is producing anything or not. So, and the reason this is critical and the reason it's important, and I'm pointing it out and hyping it up right now, is because a lot of companies are essentially shut down, or they're operating a little differently right now. Everybody's at home, yet they still have fixed costs that they have to be paying. For example, how many of you are wondering, hey, can I get my money back for my parking permit? You paid for a yearly parking permit. But we're not going to school. We don't need the parking permit right now because we're going to be doing all of our classes all summer online. Now, you guys are probably lucky as students. You can probably call the parking and transportation and cancel your parking permit, which, by the way, I highly recommend that if you bought a yearly permit. But me, if I cancel my yearly annual parking permit, I lose my coveted space in the 1B parking lot next to Melcher Hall. I don't want to lose that. So my point is that there are certain fixed monthly recurring costs that companies cannot get out of when things change, like we're all working from home, or you have to reduce your workforce because of market changes. What other costs are should be considered when you're assessing the cost of a network? Cost of the circuits, cost of the hardware. The largest costs, by the way, have nothing to do with the hardware, have very little to do with the hardware and even the software cost, of course. Software, but there's also training. And there's also management. The management and the operation costs, those are the most expensive things you can do. 60 to 70% of your MIS budget is paying for the salaries of the MIS people, which is you guys, hopefully, if you get jobs in this area, or the help desks, or the contracts that you've signed with companies like Salesforce, or companies that are providing your online help desk experience from the Philippines or India or whatever. That's why so many of those help desks are outsourced, by the way. 70% of your budget is people. So when you're considering how to keep costs down, when you're designing a new network, should you pay much attention to the hardware costs? Well, no, not so much, not as much as you need to pay attention to the reliability of the hardware and the service. You need to look at contracts to make sure they're giving you that 5 nines uptime, the 5 nines. That's what we're trying to shoot for. You need to make sure they're giving you SLAs. What is an SLA? What does that stand for? Oh, they did send refunds for your parking pass, and that's great. I'm glad you guys got refunds. I have the option to get a refund, but again, I'll lose my space in in the gated parking lot. And I pay probably more than you guys. I pay almost $800 a year. Yeah, service level agreement. That's what SLA stands for. By the way, make sure you know what a service level agreement is and how it relates to the 5 nines. And understand that people, humans, cost the most money. In a network. What other kinds of costs? And I asked a specific question on the test about what maybe is a cost to not consider. And here's something to think about that's not in the book. And it's something that I don't recall if I talked about in class, but let's just talk about it right now. The cost of disposing or removing old equipment, old data, old processes. A lot of times, this is not considered, but it's something that probably should begin to be getting considered in terms of the cost, because sometimes it can be significant. One of the things that you don't want to do when you're redesigning a network is you don't want to leave the old crap laying around. Why is that bad to leave old stuff laying around? When you guys go get a new car, you decide to change cars, you don't leave your old piece of crap in the driveway, do you? Or maybe you do. Like me, I have 5 old cars, but the point is that most of you either trade it in or get rid of it because it's in the way, it's costing you money to have. Why do we have, I'll give you a good example of a huge waste of money in terms of management, is we have the Astrodome still sitting there, and we have Reliant. What is the Astrodome doing for us? Is it making us money? Is it providing any sort of value? Sitting there next to Reliant, provides homes for rats. In other words, it doesn't do a thing. Instead, it costs money. It costs $2 million a year to maintain the Astrodome. It's basically a giant parking garage. It's not even a parking garage. It's a giant tent. Maybe they'll put all the bums that are on the street after they get corona. They'll put them all in there. I don't know, but something needs to happen. You need to get rid of it. My point is, don't leave the old shit lying around. Get rid of it. Don't leave the old people lying around. Get rid of them too, unfortunately. But I don't mean get rid of people. I'm saying if there are people that refuse to learn new techniques to save you money, then you got to lay them off or get rid of them, or they have to learn. They have to learn to adapt. They should make it a hotel. Yeah, they could. So those costs, I've not seen a lot of companies considering those costs. They can be significant, but the cost of removing the old equipment, old data, old processes, not common. My point is, remember that, but understand that all of those other things that I mentioned, these are the more important costs that you need to consider. The reliability of the hardware, the reliability of the contracts, the reliability of the vendor themselves. Sometimes organizations go with the lowest bidder which might not be a good criteria to use for who you should go with when you put out RFPs. The lowest bidder many times, and this is what happens in the state of Texas. We have so many of these highway projects that we begin and then they stop in the middle. Anybody been driving down a road recently where they were widening it and then suddenly nothing seems to be going on? It's been sitting there for 6 months, not finished. And that's because the vendor that they hired was the lowest bidder, but they went out of business. Yes, every road in Houston, exactly. Lately, it seems like that. All the roads are half done. And that's because the state of Texas and the city of Houston give their bids to the lowest bidders. The vendors bid too low, and they went out of business because they couldn't pay their payroll. They couldn't make their payroll, and people walked away and got other jobs, so they go out of business. Then it costs you more money in the end to have to go with another vendor who might say, look, we're not gonna use that old stuff. You got to tear all that out and use our stuff. So cost, very important stuff. That's why Chapter 6 in network design is so important, because there's such a huge cost factor involved. Doing something wrong in the first place can cost you a lot more money down the road. Or not doing something fast enough. We never look more than 3 to 5 years out, by the way. In fact, usually it's 3 years out. When we're redesigning a network, we never look beyond 3 years because we don't know where we're going to be in 3 years in terms of technology, in terms of hard drive capacity, or is everything going to solid states, or is everything going to now, even solid state drives aren't the thing to use, by the way, anymore. It's NVMe drives now. Or not even buy your own hardware. Everything is migrating into the cloud. So companies are instead buying services as a commodity. They're not buying hardware. They're not buying servers. They're not buying storage space. They're buying subscriptions to everything. So that's it for Chapter 6. Chapter 7, or Chapter 7, as it's also known as. Chapter 7. Going back into Chapter 7 PowerPoint notes, what's the difference between a dedicated server and a peer-to-peer server, and what are some examples of dedicated servers? Just to understand that most servers that are headless are dedicated servers. Headless servers means there's nobody sitting at them, there's no screen, and there's no keyboard. That's everything in the cloud is headless. Web servers, email servers, storage servers, file servers, Zoom servers. Peer-to-peer networking is used, though, for when we need to share data between each other. Like right now, we're all engaged in a peer-to-peer application layer network known as Zoom. So make sure you understand the conceptual difference between peer-to-peer networking and client-server-based networking. What are the basic LAN components? You have your client, you have your server, and you have your interconnecting devices. And then finally, you have your circuits. That's really conceptually the only four components of a LAN. And sometimes the lines blur between a server and a client. Some clients are also servers, and some servers are also clients. The internetworking devices is anything that's not a client or a server whose primary job is to simply move data from point A to point Z, and they're somewhere in the middle of that. And then the circuits themselves is the pathway. Those are the roads between point A and point Z. They may be physical circuits or they may be logical circuits. At the layer 3, circuits are logical. When I'm passing data from my computer to some other computer in the cloud, that's a logical circuit that gets created at layer 3, and also at layer 4, the transport layer creates a circuit there by setting up the session. The data link layer is a physical circuit. It's actually talking to the physical layer, and it's responsible for getting data to the next physical hop, which most of you got that answer close to right on exam 1. I gave most everybody something like 1.9, 1.8 to 2.0 points on those questions. But if you weren't quite spot on, I gave you 1.9, which is still 95%. That's pretty good. Know the differences in potential speed ratings between these different things. By the way, let me just point out, a lot of you guys put, when I asked for layer 1 protocols, a lot of you guys put 802.11 or 802.11n. That is not a layer 1 protocol. Okay, do you guys understand why, or do you agree or disagree? That is not a layer 1 protocol. That is a protocol suite that combines layer 1 and layer 2 together. It's primarily a layer 2 protocol. 802.11n specifies the frame sizes and what the data looks like. The N thing, that specification says we're going to use this kind of networking protocol on top of 2.4 gigahertz wireless or 5.0 gigahertz wireless. So I gave most of you credit, but a real layer 1 protocol would have been 2.4 gigahertz or Cat5 or Cat6. Okay, by the way, speaking to this. So the best way to know this stuff, and if I ask questions about why would you use one physical layer protocol over the other, understand why one is better than the other. Why is Cat6 better than Cat5? Why is fiber better than Cat6? Why is wireless better or worse or not better? Why do we use wireless versus wired in some situations? Why did twisted pair wiring get so popular for LANs, even though it is inferior to coax? And coax, by the way, was the predominant LAN physical layer protocol, but just twisted pair or TP, maybe that's why everybody's buying TP. It is the predominant physical layer protocol right now because of all the wiring that already existed in all the buildings and all the homes already. The Ethernet guys got together and said, what can we use that's already there? What roads are already in place? What tunnels are already in place that we can use so we don't have to dig new tunnels? That's where twisted pair came from, and it got so popular. It's not really the best networking protocol at the physical layer to use. What are the properties of fiber optic cabling, and what are the logical advantages and disadvantages? Make sure you know the difference in the fact that there are disadvantages. You don't always want to use fiber optics because in many cases you don't need to. What are some of the properties of fiber optics? It's expensive. It's expensive. It's dangerous to work with. It is not easy to work with because if you cut a fiber optic cable, it's not like you can use a $10 tool like we did in class and splice those two pieces back together. It's more like a $2,000 tool. It's not a tool that a lot of network managers are going to have in their back pocket. And you're never going to get a perfect connection anyway. What media is most commonly used on LANs and backbone networks and WANs, and why do we use certain media? Kind of goes towards wireless. Yeah, and you do have wireless on backbones and WANs. You can have wireless on those. Certainly, if you're in the middle of the country and your internet connection is a satellite connection, that's a wireless connection, but that's your WAN connection. Some oil companies use WAN connections. They have private satellites that they use. Very expensive to use private satellites, but some companies do that. Make sure you know what, let's see, here we go. What's the difference in function and complexity between these devices? Hub, switch, router, firewall, gateway. Just Google or look at my notes for what each one of those items is and be able to comfortably describe to me. If I ask you, what's the difference between a hub and a switch? Or why do I call this thing a gateway and not a modem? Or why do I call this thing a modem and not a gateway? Make sure you can describe and pretend it's not me. Pretend you're describing this to your mom or your dad or somebody who's not technically savvy. They keep referring to the thing on their desk as a modem, and you have to tell them, well, no, that's actually not a modem. That's a gateway because it provides DNS services and VPN, and it's got Wi-Fi built into it, and it's got a layer 2 LAN switch in it, and it connects you to the internet. So it's really a gateway, not a modem. Okay, make sure you guys can comfortably describe that to whoever asks you. What's a network profile and a user profile? I didn't talk about that too much, but basically understand in terms of network management why everything that we access has to have a user profile. Has to have a password or some identifying item, a key, something that gives you access or uniquely identifies you or the device. You can have devices talking to other devices. When a device talks to another device, we don't call it a password. What do we call it? And this might be a question on the test. When two devices, two servers, for example, need to talk to each other to share data and they need to trust each other, it could be called a token, but the more generic term for it is called a secret. So humans use passwords and log in with a user profile that compares an encrypted password that you typed in, or it could be something that you are. Passwords can be either something that you are, something that you know, or something that you have. It's either your thumbprint or a card or a password that you can type in. Things where servers are talking to each other in order to share data and trust each other are called secrets. And a token is one type of secret method. What is a domain? Domain. And make sure you know what that term TLD, a top level domain, is. What's the difference between a web domain and a Microsoft Windows domain? They are different. Microsoft uses that term differently. They call a domain as a relationship of data and people on a LAN, whereas the internet knows of a domain as a relationship of a company and people and devices that might exist throughout an entire world, but it's a relationship of some type. And the TLD names are all the extensions. Those are the .coms, the .net, the .org, the Rahi told me there's a TLD of .wtf. So I'm going to go register jake.wtf or 44 subnetting.wtf. Make sure you know what those are. Who controls DNS? And why do we use DNS? Why is DNS good? And could you surf the net without DNS? And the answer is absolutely yes. We don't need DNS. All that DNS is it's our directory. Understand how DNS works. There is no one DNS in the world. There's no one directory in the world. They all communicate, well, not all of them, but it's a global communication. There's thousands and thousands of DNS servers that are all sharing data and talking to each other and attempting to stay synchronized. It doesn't always work in a perfect world. But DNS is so that we don't have to know IP addresses. So we can type in names. You can go to profjake.com or uh.edu. There's a lot more to DNS. And I could teach just a whole semester, a whole class just in DNS and DHCP. There's a lot more to those two things. What is DHCP and why is DHCP another thing that we use? By the way, DNS and DHCP, what layer protocols would you say those are? If I had to ask you, are those layer 2, layer 3, layer 4, layer 1? What is it? They are actually, they don't really fall into, I dropped my mouse. They don't really easily fall into the network model properly. Again, they're either a protocol suite, or if I ask that question, which I won't on a test, those are application layer protocols. You run a DNS application, which goes and looks up the data for you for purposes of allowing the network layer to work properly. So a lot of people mistakenly, a lot of network managers mistakenly say, oh, DNS, that's a network layer protocol, or DHCP, that's a data link layer protocol. No, it is not. It's application layer, but it doesn't really easily fit into the internet model. Not everything easily fits into the internet model, like 802.11, for example. Make sure you go Google those two things or look it up in the notes and be able to describe to me as if I'm your dad or your mom, what DHCP is and why we use it to make our lives easier. Why is Ethernet the dominant data link protocol and who developed it? Remember how we talked about Ethernet was developed by a bunch of DICs, DEC, Intel, and Xerox, which starts with an X. It could have been called the DICS network, but they thought, well, that sounds kind of rude, so let's call it Ethernet. They could have called it carrier sense multiple access with collision detection and collision avoidance network, but that was too long. So we call it Ethernet. Ethernet originally or logically, is it a star or a bus topology? Now this is tricky. Ethernet is bus. It's a bus topology. Logically, physically, we lay it out as a star, but logically it still works as a bus topology. If you don't know the difference, go back and look in the notes or go Google for Ethernet bus topology, Ethernet star topology. Most Ethernets are not laid out in a star, or a bus or a ring. They're mostly laid out in a star, where you have a central connecting device and nodes that connect to it from there. What's media access control, MAC? Why is it needed on a LAN segment and not WANs? And that's because MAC is designed just to carry frames, not packets, designed to carry frames to devices that are physically connected to one another through circuits, through local circuits. Know what the difference between these different Ethernet protocols is, 802.3, 802.11. Then know what a VLAN is. There's a lot to chapter 7, by the way. There's not going to be this many questions to chapter 7 that you'll get, but you might get unlucky and get 20 questions from chapter 7. Hopefully not, but you might. I hear somebody talking in the background there. What's a VLAN or VLAN? I didn't spend a lot of time on VLAN, by the way. But understand from a VLAN, first of all, what's that stand for? VLAN. We already know what LAN stands for. In the networking world, the letter V almost always stands for virtual. The letter W almost always stands for wireless, but not always. Sometimes it stands for wide. It stands for virtual. Virtual LAN is basically, how do I set up two LANs that are physically disconnected from each other and make them look like they are on the same LAN? You can do them based on port-based VLANs, Ethernet-based VLANs, based on a MAC address. You can do what's called VLAN tagging and actually put the VLAN number up to 4,096 VLANs. That's what most switches can handle. So you tag the traffic coming into and going out of a computer, and it can live on two physical LANs or two or more logical LANs, excuse me, not physical, but logical LANs. It can live on one physical LAN, 2 or more logical LANs, and you can specify frames coming out of a certain program. For example, if it's a Zoom program, for example, like what we're using, you can say that's on VLAN 1, and any other traffic coming into and going out of my computer, web traffic, for example, email traffic, that's VLAN 2. And the frames coming out of your computer are tagged with either a 1 or a 2. And when they hit that switch, if you've set up your switch to give priority to one or the other, you're participating in a VLAN. Many, many companies do that so that when they're doing video conferences like what we're doing right now, that the video and the audio doesn't get choppy. Hey, Ella, lost you for a minute there. You guys keep popping off and on. So VLANs, VLAN tagging, make sure you know what those things are and why we use them. What are some things to look at on a server when determining bottlenecks? And what were some of the things I said in class? What is the biggest bang for the buck in a server? Headless servers. What's the biggest problem with most servers? Not enough RAM. RAM. Add solid state memory. Hard drives are slow, RAM memory is fast. Excuse me. Especially if it's not just a file server, if it's an application server actually running the code and your workstation is simply just a dumb terminal running a web browser. Make sure you know what network address translation is and why we use it. It's so that we don't have to have everybody has to have a public IP version 4 address. You don't have to become an expert, and you're not going to become an expert at NAT just from me teaching it to you in the class. By the way, for those of you that want to do some extra credit, I'm working on an extra credit, or some of you that need to replace a missing grade, I'm going to have you do more research or set up a NAT-based network. So that, and I recommend everybody learn how to do that anyway. Set up a firewall. What is a firewall for? Oh, and what's red versus green? When we refer to a red network versus a green network, there's also an orange network, and there's also blue networks. Most importantly, red and green. Green networks are typically your LAN, and your red network is typically your backbone, your public internet. What can you do on a LAN to increase throughput to and from a server? Add more lanes on that freeway, for one. Reduce the traffic. Increase the circuit speed. Reduce the demand, those 3 things. What does WLAN mean? That's wireless LAN. What are the advantages and disadvantages of wireless? Why isn't everything wireless? Primary reason, security. It used to be cost. Wireless LANs were more expensive. Now they're cheaper. Much, much cheaper. It's much more expensive to hire somebody to put cables in a building than it is just to give everybody a laptop. A lot of companies just give their employees laptops. You don't even get real desktop computers anymore because that solves several things. Laptops all have batteries in them, so if your power does flicker off and on, unless you have a shitty laptop like me that I'm using here, or one I need to work on here, the power will stay on even if the power goes out. 2 common radio frequencies used in WLANs. Excuse me. That's 2.4 and 5.0. 2.4 gigahertz, 5.0. Which is better? Which has longer range? Why is 2.4? Why do we use 5.0 sometimes over 2.4? And the answer basically is that two things. One, we can get a little bit more speed, not a lot more, but a little bit better speed from 5.0 because the frequency ranges are wider. We're sending more waves per second, but also because it's a less crowded band. There's less stuff in that range. Less people in that room. It's a smaller room, but there's less people in it. Different WLAN modes. No, basically you need to know the difference between what an access point is or simply called an AP, and a bridge mode or gateway mode. Bridge mode is basically using a wireless connection to connect two physical LANs together. An access point is providing a doorway into your wired LAN with wireless signals. There's actually generally 4 modes to many of these access points you buy. They're either straight gateways, access points, client bridges, or universal bridges. But make sure you just need to know the difference between access point and bridge. Make sure you know what an SSID is. What's the difference between wireless X? Oh, I just answered that. WDS. What is a WDS? Mesh network. We don't typically do mesh networking on LANs like we do on WANs unless it's wireless. We do mesh networking on wireless in large environments because they're easier to manage, especially if we have a lot of wireless devices and they move around a lot, like at U of H, for management purposes and for better coverage of the area. What are the common ways to perform wireless security on WLAN devices? And why is security much more important on wireless devices? And that's because we don't have physical control of where those radio waves go and come from. So with WLAN networking, security is a premium. Security is the most important part of wireless networking, because you're essentially opening the window to your network and you're allowing any bird that wants to fly into that window to come in, or any bird that wants to fly out of the window to go out. Okay, that's pretty much it for chapter 7. Now chapter 8, backbone network. A lot of the things are similar in chapter 8 to chapter 7 and chapter 9, but make sure you understand what that term subnetting means. And that's why you're doing that subnetting assignment, by the way. You're basically creating several little networks that are connected together in a backbone network. The 129.7.0.0 is the backbone. What's the difference between a routed and a switched backbone? And that's the difference whether it's layer 2 or layer 3. Why would I use a layer 3 backbone as opposed to a layer 2 backbone? Slows things down a little bit, but gives you better control. You can't really control things easily at layer 2, but once you give it an IP address, you can more easily control it. You can filter it. You can filter out traffic based on IP address ranges, for example. Very difficult to do that with MAC addresses. What is an MDF? Main distribution facility. What is a POP? A point of presence. Make sure you know what all those terms mean. If an organization does not have a POP in your area, the common carrier, they cannot provide services to you. That's kind of more chapter 9-ish, but like I said, a lot of chapter 8 and chapter 9 kind of blend together. And there's not a lot of data points from chapter 8, nor have I published the full video of chapter 8. We just touched a little bit on chapter 8, but not a lot from chapter 8 because it's all in the, not all of it, but a lot of it's in other chapters. I do ask a question or two about what a U is. What is a network U? How tall is it? It happens to be 1.75 inches. A network rack, and it's 19 inches wide, 1.75 inches tall. We'll talk more about U's later on when we start talking about data centers. What's a patch cable? What's a patch panel? And how do those relate to the MDF? Now, why do we use patch cables and patch panels as opposed to just running LAN or WAN cables directly into switches? What is QoS? Why do we use quality of service? That's another way we can tag our packets or tag our frames. If we're not using VLAN tagging to say a particular application exists on a particular VLAN, we might say, well, maybe this computer doesn't exist on a certain VLAN, but the application data that's coming out of it has a certain identifier that says this is a voice packet, or this is a video packet, or this is an email packet. Treat it as such, or treat it appropriately. That's what QoS stands for, quality of service. In order to use QoS and VLANs, all of the equipment from end to end on your LAN, at least all the way up to the point of it leaving your network, has to be aware of it. Everything has to speak QoS, everything has to speak VLAN, or you're not going to pass traffic. Why do we use it? And that's because of this issue, convergence. What does convergence mean? With respect to data and networks. What does convergence mean? Yeah, are you saying I need QoS in particular? Is my stuff stuttering? Or just in general, it's stuttering? I may be stuttering if I've got, it might be me. I don't know if it's just you. Am I stuttering to anybody else? It's used for, okay. So it's just you, Rahi. Sorry, it's because you're downloading a bunch of illegal programs in the background, probably, right? It might be. Now I'm on a wired connection on this computer, so a lot of times you do get quality issues on Wi-Fi, but the reason that we use quality of service and VLANs is to prioritize. That's the key for prioritization of traffic. Who gets to go first? Who gets to come into the club first? You don't need to wait in that long line. You're important. Come on in. You're a VIP packet. So you can think of VLANs as VIP. VIP passes for packets. Convergence, the reason we have to do that is because now we're carrying not just email traffic, not just web traffic, but voice traffic, video traffic, instant messaging traffic, all kinds of traffic. Everything that we do now in terms of communication is all carried on the same network. We don't use separate networks anymore. We don't have a separate phone network anymore. We don't have a separate television network anymore. Most of you don't watch TV on a separate cable coming into your house or the radio airwaves or radio waves. You listen to music over the internet. You watch TV over the internet. You speak on a telephone over the internet. In other words, over the same LAN. So the term convergence means all of those technologies have come together into one location or one lane. Everybody's getting on that same one lane freeway. There's lots of advantages to doing convergence. Okay, and in chapter 9, finally, so we're not going to get to chapter 10, by the way, today, which is okay. I want you guys to concentrate on finishing the subnetting assignment, asking me questions, and then going through this study guide and make sure that you can comfortably answer on your own. And you guys might want to get together with each other over Zoom and maybe ask each other, okay, describe to me what a WAN is and what's a LAN. So in chapter 9, we just went over chapter 9 in the last class, and it's that Zoom session is published. If anybody's having trouble finding me on YouTube, just go Google for YouTube space Prof Jake or YouTube space Jake Messenger, and you should find my YouTube channels. I've got an MIS 4477 channel. I've got an MIS 4397 channel. And also on Blackboard, I occasionally, not all the time, but I'm posting the links specifically to the YouTube videos. So common carrier, make sure you know who a common carrier is and what their primary job is and why do we call them a common carrier as opposed to a private carrier. What is DSL? Don't spend a lot of time. In fact, you can kind of ignore that. We didn't talk about DSL. It's a technology that's kind of going away. dead, sucky techno, dead, sucky, latent technology. That's what that stands for. Not really, but that's what we're pretending it stands for. DSL, we hardly knew you. Actually, ISDN was before DSL, but those are two data link protocols, which you probably won't have a lot of experience in having to use. Maybe legacy wise, you'll be replacing some DSL circuits. So don't spend a lot of time on it, in other words, but I may ask one question on it, like what's replacing DSL, Metro Ethernet, coax, other things that are replacing DSL. Describe in WAN topology a star network, a ring network, a partial and full mesh network. What's the most common? What's the most and least expensive? What are the pros and cons to using a mesh network over a star network? Why is a star network the most common? If money was no object, why would everybody want a full mesh network? Because it's extremely redundant. What is that term? Point of presence. Who owns the topology of a WAN? Usually it is leased. Sometimes landlines are also called leased lines. By the way, has anybody ever heard this term, dark fiber? What is dark fiber? I didn't mention it in class yet, probably doesn't mention it in the notes, but dark fiber, and no, it's not something that an investigator finds at a murder scene. Dark fiber means that is fiber optic cabling that has been laid by a common carrier or a vendor in the area, but there's not currently any signal on it. You as a company can rent that dark fiber and put your own signal on it and run whatever speed networking and protocol you want on it. In large cities like Houston, New York, Chicago, Detroit, there are dark fiber rings where companies simply install the fiber. In other words, they install the freeway, but the freeway has no users on it, has no controls on it, no toll booths, no police, no speed limits. And then you as a company might choose to rent that dark fiber leg from point A to point B, North Houston to South Houston, for example, or Houston to Dallas, and you can do whatever you want with it. So that's another term that you need to be familiar with. It's not as common and usually only relegated and used by large companies that don't want to have to run their own fiber optic cabling. It's not just a rented service, it's rented circuit, physical circuit. Whereas most WAN topologies that you lease are renting services. You're either renting packet switch services, either dedicated or packet switch services. That's the most common WAN connections. Metro Ethernet, for example. If you want another example, by the way, of another carrier, sometimes this helps. PS Lightwave. They're a local company. They're also called Phonoscope. That's their own old name. They have lots of dark fiber and lots of fiber in Houston, and they're the biggest competitor to AT&T and Comcast, which are the two big players in Houston. AT&T, Comcast, and then Phonoscope. And then there's several little small providers that only provide WAN access downtown or in the medical center or certain areas like that. So I suggest if you've got time before you take the test, at the very least, go to these companies' websites, PS Lightwave, Phonoscope, AT&T, and stick the word WAN or leased lines after your Google search and go see what kind of services they offer, because a lot of times in those online sales documentation about what they sell, it starts kind of making sense. Oh, we have a Phonoscope, or PS Lightwave has a fiber ring, a 600 gig fiber ring all over Houston, for example. Might make more sense when you see marketing material that kind of ties the tech material together. What's T-carrier service? T1 versus E1, and what's OC services. Just talked about these in the last two classes, so this should be very fresh in your mind. What's dedicated versus shared? Why would a company use one over the other? Security, cost, speed. What's a major difference between ATM and Ethernet protocols on WAN? ATM is what DSL uses. Ethernet frames are much larger. ATM frames are much smaller. That's one reason why DSL is not that good, because DSL frames, 53 bytes. That's very small. It's basically like your LAN data is using a bunch of bicycles or unicycles to get everything around versus using a big truck to get everything around. Since it's a heavily shared network, they have to make all of their frames maximum sizes very small because it's very busy. It's a busy network, busy freeway. We don't want to put a bunch of semi trucks on a busy freeway. We want to put a bunch of Suzuki Samurai motorcycles on a busy freeway so that we can all get from point A to point Z faster. Point A to point B, I should say. What's a VPN? What is a VPN tunnel? I just talked about that in the last class. Advantages and disadvantages. What's the biggest disadvantage to using VPN, by the way? Or what are a couple of the biggest disadvantages? VPNs aren't the greatest things in the world. They're complex to set up. Were you going to say something, right? I saw you light up there. They're complex to set up. They're slow and they're shared. You're sharing data with, and you're left up to the mercy of whatever your internet connection is. Also, although the book and the notes might say VPN is secure, I argue that VPN is probably the least secure method of WAN technology. Like I said before, when you start going higher up in your layers, up here to application layer, which is where VPN lives. VPN is an application layer suite of protocol or an application. Again, it doesn't fit really well into the internet model. It fits throughout the entire internet model. It is a concept where I'm taking everything in an application, encrypting it and transforming it in some way and making it look like something else. But with a username and a password, I can hijack VPN traffic, or I can get on a network. So it's not secure because of that. What is those two terms, internet versus extranet? Intranet, intranet, extranet. Make sure you know those three. Dynamic routing versus static routing. Which is better? Which is faster? Dynamic versus static. Anytime I ask that question, what is faster, dynamic versus static? What's the answer? Pretty much with respect to anything in networking or anything in the world. Dynamic means, well, we don't know exactly, we need to drive from here to Dallas. Well, how do we get there? Well, I'm not going to pre-look it up. I'm just going to figure it out on the way. I'm going to dynamically figure out the best way to get to Dallas. I'll see if there's traffic on the way and maybe take a detour. Versus, I want to map it out to start with, and I've got my specific routes already known before I hit the road. That is static mapping. That's static routing. Which do you think is probably faster when you actually get on the road to go somewhere? Isn't it probably faster to pre-plan your routes from point A to point Z when you're driving somewhere? To check the times of days to make sure that, you know, these toll roads are open during the time of day and that they're not busy. My point is, doing things dynamically is always a little bit slower than doing things statically. Why do we do things dynamically so much on LANs and WANs, like DNS or DHCP, for example, Dynamic Host Control Protocol? What are we giving up? Why do some people, rather than planning, hey, what do you want to do for dinner tonight? I don't know. What do you want to do? Let's just play it by ear. Let's not pre-plan. Let's play it by ear. Why do some people do that? Dynamic is easier. Maybe easier. Dynamic is more able to adapt with changing situations. or it's easier for the end user, not the network manager, because the network manager has a little bit of work to do to set up a dynamic network or DHCP, but it's easier for the users of a network to not have to worry about how do we get from point A to point Z. I don't care. I'm just going to get on the road and there's going to be road signs that will lead me there. I don't have to look at a map because every 5 miles I'm going to see, or I'm going to be told by my phone, for example. It's like the equivalent of using MapQuest or Waze, or what's the other thing? Google Maps, to tell me where to go as I'm making those turns, but it is a little bit slower because I'm having to pay attention to it. So dynamic routing is usually better in a large environment where things change a lot. There's a lot of traffic, or the traffic quantity changes, but you lose about 3 to 5% in terms of overall speed throughput. So keep that in mind. Dynamic routing and DHCP is always the best. If you need 2 servers to talk to each other all the time, or you need a server, or you have something that has some data on it that you need to get to all the time, and it's a pretty critical need, like you need to access this webcam all the time, you might be better off statically assigning an IP address to that thing and making a static connection to it, not a dynamic connection, so that you can get to it every time, so that you don't have to rely on Waze or MapQuest or whatever to tell you how to get there. You already know in your head how to get there because you were the one that pre-programmed it. What are some things to consider when selecting WAN services? Well, a lot of these things are similar to when you're selecting LAN vendors and LAN hardware's cost, but you have to consider, and this is why I mentioned MRC before. It goes back to chapter 6 and chapter 7, designing networks and LANs, monthly recurring cost. This is much more important for WANs, much more important for dedicated services, because this will kill companies. So many times a company, like right now, I'm dealing with a customer or a potential customer that signed a contract, a 5-year-long contract, 5 years. And they are paying over $5,000 a month for a 20 megabit per second fiber line to feed to connect 2 buildings that are physically 1 block away. And these are not big buildings. They don't have a lot of employees, and there are maybe 20 people in one building and 10 people in another building. And I said, dude, guys, you could have set up VPN, or you could have done something for $500 a month, or even 75 or 80 bucks a month in either location, and just use VPN and use internet connections. Oh, well, let's do that. Let's call Comcast and cancel that $5,000 a month contract. Well, guess what? They don't let you cancel it. It's because they had to spend a bunch of money to run fiber down the street. Comcast probably paid $17,000, $20,000 to a vendor to run fiber in a channel 1 block down the street. So they want their money back. They want to recoup that money. So those costs, the biggest cost to consider is your monthly recurring cost on WAN connections. The fact that you're renting, just like when you rent an apartment. If you got a temporary job working somewhere, you're not going to rent an apartment for a year. If you're only going to possibly be there for 3 months, you might get stuck renting that thing. So you might just live in a hotel for 3 months. It might be more expensive in the short run, but you're not going to get stuck with a big, long contract. Leasing versus owning, for example. Okay, so that's pretty much it for the notes. I need to get ready for the 4 o'clock class. Any questions? So, like I said, you can take exam 2 now. I would go through all of these data points and answer them in a separate document. Take this like a WordPad document, copy and paste all of these data points into a brand new document, and go here, copy, paste, and then go answer each one of these items on your own. What is OC service? Go look in the notes, go look at OC1 equals 52 megabits per second. It's fiber, it's offered by, Comcast, okay? Danny made a Google Doc, awesome. Yeah, you guys are fine to share as much information as you want with each other. Just don't do it while you're taking the test, okay, guys? Take the test on your own. I was able to tell from exam one because some of your essay question answers were literally identical to each other. Now maybe that's because you copied and pasted. I want the essay questions, by the way. If I there's now there's not going to be as much essay on exam two because it is you know, you're filling in the subnetting assignment. But when I ask an essay question, guys, I want you to rewrite in your own words, even if the grammar's bad, even if English is not your first language, even if you know you didn't make A's in writing in high school. I don't care. I want it in your own words. Don't copy and paste right off the internet. You don't learn stuff that way. You learn how to copy and paste stuff really well. And it was really obvious. The fonts changed. I counted off maybe a little bit in a few cases, but it was obvious that some of you were just sharing data with each other or you were just copying and pasting. You got to convince me, guys, that you're learning this stuff. And it's only going to hurt you in the long run. You're going to get a job with somebody, and if you don't know your shit in 2 or 3 weeks, they're going to figure it out and they're going to fire you if you don't know this stuff. So do everybody a favor and learn these terms, learn this technology. You need to go much further beyond just what I'm teaching you in this class, okay? It'll just make you, it'll make you very invaluable. These days, MIS managers, I could go out and get a job making probably $250,000 a year tomorrow because I've had a lot of experience, but there's no reason why people graduating from U of H who've done a little bit of extra work and work 6 months to a year in the industry can't ask for $100K a year right now. But you need to know your stuff. You'll do very well, but you need to know your stuff. See you guys on Wednesday, same time. I'll publish this later on this evening. Hey guys, I'm recording this meeting. Some of you might be from the previous class. That's fine. If you want to sit through it again, turns out that the previous period wasn't recorded, so I'm going to use this one and publish this one. We're going to spend most of the time today talking about what's going to be on the exam because I want you guys to study for and get that done so that we can get into chapter 10 starting on Wednesday. So I'm going to go over some of the items that are going to be on the test and give you a lot of hints and a lot of suggestions. So I suggest you pay close attention. I'm going to wait a couple more minutes to see some more people coming on. As I said before, I would much prefer that you turn your video on so I can see that you are participating in the Zoom session. And use your audio and speak to me if you have a webcam. One thing you might want to do, if you don't have a webcam on your computer, use your laptop or use your computer and your cell phone at the same time and just join from both. You can join. I am in my Zoom meeting here from my computer over here, so that, and the reason I started doing that is so I see the same experience you guys see, to make sure that I'm sharing the screens properly and that I don't look like a dumbass for 5 minutes before somebody goes, Professor, you're not sharing your screen. So I thought it was probably a good idea to do that. So exam 2 is online now. You have through Saturday.
In class.
What's that? What's that about class?
Oh, nothing.
Okay, so you have from now until Saturday at midnight to start it. I think that's plenty of time. The subnetting tutorial is online, chapter 9 video. I actually published the videos, they're online. Part of chapter 8 is online from the 2:30 to 4 class. I don't think we need to spend a lot more time on chapter 8. We didn't spend much time at all on it. But that's because a lot of the data that's in there, and I'll talk about it today, is quite redundant in chapter 7 and chapter 9, because really the only differences between a LAN and a backbone network and a WAN are the scope and who uses them. A backbone network essentially glues a LAN to a WAN. And in some situations, like in most of you at home, you don't have a backbone network, you have a LAN and a WAN, or LAN and internet, that's it. There is no backbone. Is the subnet portion of the exam similar? Yes. So let me go ahead and if you have questions about it, ask me right now so I can answer all of these. The subnetting assignment is separate from the exam. There is a separate section on exam 2, which is also subnetting. It's very similar, but it should be easier than the subnetting assignment. First of all, it's shorter. It's only 5 entities versus 10. Secondly, it's smaller needs. It's not this organization needs 480 addresses. It's the largest organization I think needs under 200 addresses. So you need to pay attention to, when you're doing the subnetting assignment, pay attention to those smaller companies that you're allocating, that you don't violate the rules of IP version 4. You don't go off the end of the map. You don't hang that car off the end of the ferry, that you start on the correct boundary. It's a big mistake a lot of people make. They start in the wrong spot. They may size the network properly, but they start in the wrong spot. In other words, they have a car and they park it between 2 parking spaces rather than taking up 1 parking space. Even though they could have fit all in 1 parking space, they're taking up 2 and because they got there first, and then they're making it impossible for somebody else to come park there just because they were there first. So let me share my screen. What is advanced? Oh, cool. They've added some stuff. Zoom is getting better. You know what I should have done? You know what everybody in here should have done? You should have bought stock in Zoom 2 weeks ago. ZM on the NASDAQ, because their stock has gone up almost 100% in 2 weeks. I should have paid attention to that, but I didn't. But you guys are probably gonna say, we don't have any money to do that anyway, so that's okay. Okay, so As I said before, exam 2 is available now. You could go take it right now, but before you take it, make sure that you complete the subnetting assignment if you haven't completed it already. I extended the due date on it. By the way, several people said, let me pull out the chat window here. Several people said that they submitted it and got a 0 on it. That was simply because I allowed, and that was a function of Blackboard. I allowed you guys to potentially turn it in late. Oh, where's my chat window? Excuse me, guys. Chat. Where's the chat window? It's hiding on me. Give me 1 second. I'm trying to find my chat window. There it is. Stupid Zoom. Zoom could be better. They're improving it. So, by the way, did I answer your question, Aman? The subnet portion is similar. Yes, it's very, very similar. It's not exactly the same, but it's close. So I would say if you did the subnetting assignment and you turned it in on Blackboard, by the way, and like I said before, some of you complained that you had submitted it, the electronic version, and you got a 0. That's because the original due date was April 1st. So I changed the due date to April 11th. Go back and check your grade. You should see now a grade in there. 100 or 99.5 or 98.3. And I'll just say that if you got like a 95% or above, you're probably fine. The reason you might have not gotten a perfect 100 is because of very minor technical typos, which, like if you did not type a comment in, for example, or you typed in a weird character and I was looking for an alphabetical character. Don't worry about that. Okay, if you got a 95 and up, you probably did most of it right. So, resubmit it if you want. Do it again. Do it a couple times. Do it 3 times. Do it 5 times till you get comfortable with it. Then go take exam 2. Only after you have gone through the study guide. Here's the course content is up on Blackboard. I'm actually in the. Let me double check it. I'm in the previous class. So let me double check and make sure that this is published in your section. I'll give you just 1 sec, yeah. Guys, get a little window into what I see. What am I looking for? Course content. Basically a small scale version typed a 0 in twice. Yeah, so if you typed a 0 in twice, Danny, you probably got like 1/10 of a point off. A couple people email say, I'm pretty sure I did it perfectly. I got a 99.8. Why did I get that? Well, that's why. Okay, don't stress over that. Exam 1 study notes, exam 2 study notes. Yeah, so I updated those very recently. So we should just be able to click on it. The assigned lab, I'm going to change that, by the way, and I'm changing the lab assignment, what we're actually doing. I'm moving away from the, I'll talk about the lab assignments on Wednesday, okay? I'm moving away from it because we can't really do those experiments like we used to in the lab anymore, nor is it as important anymore because these days we concentrate less on the physical layer and more on the networking and application layer, truthfully, of networking. You guys are not iTech people, you're managers, you're management people. The primary focus of your job is going to be documenting things and managing people and keeping costs down. It's going to involve a little bit of hardware, but not much. So that percentage is probably going to change, or I'm going to assign something that's more on like designing a network with draw.io or doing less physical hands-on stuff. It's still important. It's still networking stuff. So anyway, here's the exam 2 notes. Any other questions about the subnetting assignment, by the way? That is 25% of the test. Oh, and also when you do take the test, by the way, you get 3 hours, only 30 multiple guess questions, not 40. I recommend, it's presented to you all at once, scroll down to and do the subnetting section first, okay? Do that first, even if because it might take you a long time, especially if you're not very good at this, because it's much more likely that you'll make a decent grade because there's the 30 multiple guess questions, you got a 20% chance of getting them right if you got 5 minutes left to take the test to go randomly answer those questions. If you spend a lot of time on the multiple guess questions and you got 10 minutes left to do the subnetting, you're not going to have enough time. Okay, so make sure that you skip and do the subnetting part first. Why have I only got 6 people participating? You guys need to not rely on me recording these things, by the way. Oh, there's more than 6, excuse me. I needed to blow that up. More gripes about Zoom. So let's go over the structure. 30 multiple guess questions, 2.5 points each, 1 multiple part essay question, which is basically just like the subnetting assignment where you're filling in a big chart. Online via Blackboard, when you're studying, first refer to My Notes first. My Notes override anything else, regardless of what you might read in the book or read in the internet. I'm smarter than the book and the internet. I'm not trying to be facetious about it. I'm just saying, go by what I say, even if you read something on the internet that you disagree with. I may change the way I look at things. Neil deGrasse Tyson said something very important. It's like, you never want to get to the point to where you think you know everything. You want to get to the point to where other people think you know everything and you think you know nothing, or something along those lines. So I'm always learning and redeciding what I think is right. And I always encourage you guys to do that. Don't stop learning. So if you do find something on the internet or find something in the book that contradicts what I've said to you in class, email me, bring it up in class, let me know, and let's talk about it. And we may decide, okay, maybe there's some validity to what we're reading there. Or maybe it's just plain ass wrong. I've read, you got to be careful when you read stuff on the internet, guys. A lot of it's just wrong. Particularly, not so much the technical stuff, but a lot of the historical stuff. It's just wrong because people are guessing on a lot of it, or they don't know the real story, or there was controversy involved. So look at my stuff first, then look at the notes from the book and the PowerPoint presentations, then go to Google. I noticed in exam 1, I could tell which ones of you didn't look at my notes, you just Googled everything on the test because you put in the essay part in particular, the first thing that popped up in Google, which wasn't right all of the time, or it didn't speak to it with respect to exam 1. So there were a few considerably low grades on exam 1, even with the curve. Most of you did pretty well, but there was a few C's and B minuses on exam 1. I have to say the previous class did better. You guys did not do as well as the 2:30 to 4 class. So you guys are in competition with them, okay? Bring it up, bring it up. So pay more attention on exam 2. Online test. You guys can work all that you want together, figuring out the subnetting. Danny here is sharing in the Zoom chat there. Can you guys see that in the chat? He's sharing a Google Doc. What is in that Google Doc, Danny, by the way? How to make an A in Jake's class. Oh, the review, just this thing here. What is it? An annotated version of the review? Or is it just the same thing we're looking at right now? Okay, so I guess I need to go take a look at it, make sure you haven't violated any of my copyright rules, but I'm sure it's fine. I'm not really that big of a stickler on that. All of this stuff's pretty much the same. Now, exam 2, when you take it and you submit it, it should automatically, excuse it, and it should automatically give you a grade. because all of the essay that's on there, it'll grade itself. So hopefully you'll get a decent grade. If you don't get a decent grade, don't freak out though. I'm going to go back and I'm going to manually look at everything, even the stuff that gets pre-graded, to make sure that you didn't just make a dumb mistake like you put 2 zeros instead of a 1 in a subnet mask. That's not fair to do that to you. Or put 2 WIMs instead of a 1 in a chart. So I'll go back and look at it. In terms of the content of what's going to be on the test, let's revisit some of these items. Some of these will be very fresh in your mind down in chapter 9. Let's revisit from chapter 6 and chapter 7. There's a lot from chapter 7, by the way. So if you missed the chapter 7 class, got a little bit of catching up to do. In chapter 6, know the difference between the traditional design approach, meaning the system design life cycle, SDLC. Has everybody had the SAD class yet, Systems Analysis and Design?
Oh yeah,
Don't you need to take that to get to my class?
pretty sure. I think that's a prerequisite.
Okay, so everybody should already be familiar with that term, SDLC. But we don't use that kind of design plan. We use what's called the building block approach, which is a cyclical approach. A needs analysis, which feeds into a technology design, which feeds into a cost assessment, and typically feeds back into a needs analysis, because the number one criteria is money for who gets the bid or who gets to buy what. Networking, expensive stuff, data management, networking management, cost money. What are the steps in the building block approach? So that's the needs analysis, the technology design, the cost assessment. Make sure you can specify or describe to your mom or your dad or a common guy on the street what those things mean, why they're different from each other. I'm going to go away from this for a minute and just show you. You need to go back to, this is going to help you on the needs analysis and the cost assessment part. If you remember, I published several sample RFPs here, which you should see in Blackboard that you need to go look at. They're rather complex. And you can also Google for RFP samples on the internet. But these are real world, real life samples from Fort Bend ISD and other organizations that I do business with. And this will give you a really good idea of what are the elements of an RFP, why an RFP is there, how an RFP is organized, what are the rules, and what's not in an RFP, what is and what's not in an RFP, request for proposal. I think just looking at these samples will be very, very helpful to you to allow you to understand what an RFP is. You need to become much more familiar with RFPs, because for many of you, one of your primary jobs, if not all the time, occasionally, you're going to be tasked with helping to fill in the spreadsheets for an RFP, like this spreadsheet, for example. Your boss or your cost accounting or somebody's going to say, here's a spreadsheet which lists out all the stuff that we need. And your job, where did it go? Well, it's coming up somewhere. Your job is to get those prices and fill them in. So you need to know from that chapter the difference between turnkey vendors and standard vendors. How do we get those costs? What are the key deliverables out of the needs analysis? What are the goals of a needs analysis? In other words, what flows out of the needs analysis into the technology design? What makes a technology design different from the needs analysis? Needs analysis is logical information. Technology design is typically physical information or more specific information, which sometimes includes brands. It speaks less about in terms of volumes and quantities, and it speaks more towards actual brands, compatibilities, reliability requirements. Define these terms. Make sure you know what all of these terms mean. Circuit loading, capacity planning, peak versus nominal network traffic. These are in the PowerPoint presentations. These are in the notebook. These are in the notes. It's less likely that you're going to find appropriate answers on the internet if you were to Google for these. So go with what you see in the PowerPoint and in the book notes on these. What's the difference between static and dynamic network modeling tools? I've already mentioned draw.io, and I recommend, by the way, you will have assignment that will be due by the end of the semester that you will need to do in draw.io, which I'm going to make mandatory. Originally it was optional, but it's mandatory now. Where you're designing a network, it is an example of a static modeling tool. Static modeling tools have their advantages. Primarily, they're cheap. Dynamic modeling tools allow you to basically draw a map, or they will discover your network for you and draw a map for you, and then allow you to put in simulations of increased traffic, for example. They typically cost money and they're complicated programs, and some companies charge you thousands of dollars to run these modeling tools on your network. And sometimes spending thousands of dollars on a tool like that is necessary, because making a mistake in the beginning when you're designing a network can be very costly later on, because most network designs, the outlook or the distance of how far out we look is never more than 3 to 5 years. We're redesigning our networks at least every 3 to 5 years. And that's because technology changes so often. And not just the technology, but the needs change often too. For example, right now, the needs for remote access and working from home have demanded design changes in networking, which we didn't necessarily foresee. But so it's not just always technology design, it's demands that change. Things become too expensive to manufacture in one country, for example. So we have to figure out how to make it in another country and provide communication to that other country. We cannot do things face-to-face anymore. We got to figure out how to do that online. So we never look further than 3 to 5 years out, because of not just technology, but demand changes as well. So try to make decisions as best as we can, because again, we go back to this, the most expensive thing that most companies do other than paying people is managing a network. Second most expensive thing, unless your company's in the business of building airplanes, or you're a communication company, the most expensive thing you do is, second most expensive thing you do is pay your MIS managers and buy networking equipment and manage networks. What's the difference between static and modeling versus simulation? What's the turnpike effect? Make sure you understand what the turnpike effect is on networking. What causes it, how to mitigate that, and that typically is you underestimated the traffic needs of a network. Always, always, always overestimate. I always tell network managers, whatever percentage you think you come up with in terms of gigabits per second or megabits per second, or how much hard drive space you think you need or storage space you need in the cloud, triple that. Triple it or quadruple it, because two reasons. One, because technology changes, or the demand changes, and convergence and things that we normally used to do on paper, that we used to do face-to-face, we're now doing on the internet, so the demand is much greater. Also, the fact that technology does change. What changes? What do you guys see changing a lot in technology in terms of cost? Stuff gets cheaper, or stuff gets bigger and stays the same price. Hard drives, for example. Anybody bought a solid state drive recently?
Yes, SSDs are getting more and more memory, but they get crazy expensive.
They do get crazy expensive, but also they get crazy cheap too. I just bought a 240 gig SSD here that I'm going to put in one of my laptops. 240 gigs. I paid, I don't know how good it is. I guess I'll find out. I paid $35 for that SSD drive. This thing is literally 100 times faster than the hard drive that's in that machine. Now, will it last as long? No, probably not. It'll probably die a couple years from now. But as long as I know that, as long as I plan for that, and know that it might, a spinning disk, you got a 12 terabyte for a new one. I'm sure it's not a NAS drive. I was just pricing some drives out. I can get used 4 terabyte drives for like $30 that are pretty decent. So anyway, that's another reason why you never look more than 3 to 5 years out, because the prices drastically drop on a lot of things. What kind of cost do you consider during cost assessment? I talked a lot about this, but one thing that a lot of companies don't consider, and one of the things that we usually don't consider, and this is a big hint here for the test, removal or disposal of legacy equipment and circuits, and maybe even processes. Removing or getting rid of the old stuff a lot of times is not considered in technology design or cost assessment, but maybe it should be. I haven't read a lot about this, and I haven't studied. I mean, I've concluded a lot about this, and in my personal experiences, this becomes a big problem a lot of times. In my EI lab, for example, in the lab, I have so much legacy crap in there that I can't bureaucratically get rid of, and it becomes a management nightmare. The rule of thumb when you're putting in new systems in place is, if there's something that's laying around that's an asset that's no longer being used, an asset that's not being used or underutilized is a liability, because it's in the way. It's taking up space. It's making you worry about it. It's making you think, well, maybe I should pay attention to that. Oh, wait a minute, that's that old stuff we're not even using anymore. Assets become liabilities when they are no longer used or underutilized. Get rid of the old shit. That's what I'm trying to say. Okay. Most companies, most network managers don't consider that, because it's not traditionally part of the teaching methodologies. Removal or disposal of legacy equipment. You can't throw stuff away. You can't throw hard drives in the dumpster. You're not supposed to. You can't throw monitors in the dumpster. You cannot throw a lot of things away because they have rare earth metals, or they have chemicals in them that you're not supposed to put in the, you're not supposed to throw old media away either, like floppy disk drives and things like that, floppy disks. All that stuff has to be properly recycled. Some companies, that's all that they do. I know companies that make millions of dollars a year doing nothing but picking up the trash of old equipment, and they charge you $30 a pop to come pick up the old shit out of your office or out of your company's office. And then you know what they do with it? They turn around and sell it on eBay. So they make their money 2 times. The companies that are recycling or remarketing, IT remarketing, IT recycling, they're the ones that are making crap tons of money right now. It's probably a good business to get into. I do a little bit of it myself, but mostly I deal with those kinds of companies. So anyway, that is one of those things that is not in the book, not a typical consideration. But if I ask a question that has to do with that, that's probably the answer. Big hint, okay? So for those of you that are participating in this today, you'll probably get that one right. Define an RFP and its role in cost assessment. I talked about RFP already. What's the difference in scope between LAN, backbone network, WAN, and enterprise network? I've already talked about that before. In terms of the difference in scope, they're not particular. It's not a particular distance. It's usually a particular geographic impediment or a way of looking at the organization. What part of your network do you own and what part of your network do you lease? What part of your network do your internal employees use and what part of your network do your customers use or the outside world uses to get to you? In chapter 7, that was the wired and wireless local area network chapter. Lots of data points in this chapter. We didn't discuss everything in class, and you probably won't get all of these questions from chapter 7, but there are, it pulls from a test bank. So let's go through quickly each one of these. What's the difference between a dedicated server and a peer-to-peer server? I talked a little bit about that. Dedicated servers are also called, what's the term for a dedicated server that doesn't have a mouse and keyboard and monitor on it? It's called headless. All servers that sit in a rack in a data center, almost all of them, are headless. They don't have keyboards, they don't have monitors, they don't have mice. Those are human input devices, or Microsoft calls them HID devices. They're not needed for servers, and that's because the server, although it's layer 5, server's dealing with data, not people. Excuse me. Clients. Client devices deal with people or deal with other clients. What are the basic LAN components on a LAN? You've got clients, servers, the internetworking devices between those, and then the circuits themselves. You can have physical circuits, such as a LAN cable, or a wireless connection. That's still a physical circuit. Or you can have a logical circuit, like the pathway between me and Amazon.com, where I'm ordering stuff from, or UH.edu or profjake.com. I have a logical circuit, or I have a logical circuit between you and me right now on Zoom, but we're not physically connected together, but it is a logical circuit, which is occurring right now. At the what layer? Happens to be with Zoom, it's at the application layer, way up high here, layer 5. Know the difference in potential speed ratings between these different media types, these different guided media types, not radiated, but guided media types, Cat5, Cat6, fiber, the pros and cons, and the appropriate times to use one over the other. Why did twisted pair wiring get so popular, even though it's not as good as coax? That's because a lot of legacy wiring already existed in buildings. What are the properties of fiber optic cabling, and what are the logical advantages and disadvantages of fiber optic cabling? Fundamentally, it's different because it's not copper, it's light. We can transmit a lot more data with light waves than we can with electrical waves over copper, but there are disadvantages to it. Primarily, it's expensive. It's difficult to repair if it breaks, and it's dangerous to work with. You can't just go to Walmart and buy a fiber optic cable. You can go to Walmart and buy all the Ethernet cable you want. What's the difference in functionality between a hub, switch, router, gateway, and firewall? I want you to be able to describe to your mom or dad or somebody who's not technical. I'm being stereotypical and I'm saying your mom or dad. But anybody who's not technical, I want you to be able to describe the difference between each of these items. What makes a gateway rather than a router or a modem? What makes a switch different from a router? What is a hub? Make sure you can comfortably answer all of those if asked in conversation. What is a network profile versus a user profile? User profiles and network profiles, all of them refer to typically the hardware or the asset that you have allowed to have access to, primarily with a password. Not always with a password. Sometimes we just call it a key. Like, how do you get in your house? You get in your house with a password? No, you get in your house with a key, but it's essentially the same thing. There's a special terminology used for when servers communicate with each other. When clients communicate with servers or clients communicate with clients, we typically use a password or a key, but when servers communicate with each other to share data, the terminology used there, by the way, is called secret. Same thing as a password a lot of times, or sometimes it's a token, which is kind of like a key. Token. All of those are associated with profiles, which define what I'm allowed to have access to and when am I allowed to have access to, and to what degree. What is a domain? How is that defined? How is it related to a subnet? A subnet is typically a physical association of nodes on a network, whereas a domain is a logical association of employees or data or organization or entities within an organization, such as uh.edu. How does that differ from a LAN? What is DNS and what's a TLD and who controls DNS? Domain name services? DNS. Do we need DNS to communicate on the network, on the internet? You can't use, by the way, a 12 terabyte drive on a Dell 2950. You'll get 2 terabytes out of it, by the way. Do we need DNS to communicate on the internet? Anybody? Bueller? Anybody? Bueller? The answer is no, you do not need DNS. All I need to do to call you is know your telephone number. I don't need to know your name. Just like your computer, all he needs to know, he or she or it needs to know is an IP address, doesn't need to know a name. Why do we use DNS? For convenience. And also I'd say for speed and the ability to not have to look things up manually. Is DNS a network layer protocol, data link layer protocol? What layer is DNS? Where does it fit? And the answer is it doesn't fit very well in the internet model. It's really an application layer protocol. A DNS server, a DNS client, those are applications that run to provide networking information, but they use both the data link layer and the network layer. They get information, or DHCP does at least, gets information out of the data link layer to give you a network layer address, but those are applications. Keep that in mind. A lot of people, by the way, on exam 1, speaking of things that don't fit well into the internet model, I asked for an example of a physical layer protocol. Several of you put 802.11. That is actually technically incorrect. That is not a physical layer protocol. Even though the book might say it, even though the internet might say it, 802.11 is a protocol suite. It is a combo. It's a combination of using wireless 2.4 and 5.0 gigahertz radio frequencies, which is a physical layer protocol, with Ethernet frames of a particular size and structure. So it's a layer 1 and layer 2 protocol. So not everything fits properly into the internet model as to which layer it operates at, like DNS and like DHCP. Why do we use DNS and DHCP? Again, so that we don't have to look things up on our own, which is faster. You can also consider using DNS and using DHCP as the dynamic, non-static way to do things, which is faster. If you need to get some data off of a server, copy it down as fast as you can. Should you use static routing? Should you use should you use dynamic routing? In other words, if you want to get from point A to point B in the city, want to drive across town from one side of Houston to the other, what's the fastest way to do that? Is the fastest way to do that to get on the road, and then while you're on the road, open up your phone and turn on Waze and get Waze to start telling you the answers, or look it up before you go and do a little bit of pre-planning and put the information in your head first? The answer is put it in your head first. You'll get there faster. But, well, before I give you the but, and this is true for routing as well when we get to the routing section, static things static, doing things statically is always faster than dynamic. And that's what DHCP and DNS are. That is, I'm going to learn on the fly. It's kind of like the difference between, and I know some of you have had this, I have this conversation nearly every night with my girlfriend. What do you want for dinner? I don't know. What do you want? I don't know. Well, we'll deal with it later. it always turns into a big argument later because we don't have a good roadmap or a good thought in our head, and we spend 10 minutes deciding what we should do for dinner. So we wasted some time there. If we had just talked about it for 5 minutes in the beginning of the day, well, I'll cook something, or we'll go to Mod Pizza or whatever. We got it in our head. It becomes a static rule. Okay, we're gonna go to Mod Pizza at 7 o'clock. We got it in our head. We can be much more efficient when the time comes. So doing things dynamically versus statically is slower. But why do we do everything dynamically? Why are all of our networks, with respect to workstations, why is everything set up with DNS and DHCP and dynamic routing versus static routing? Why do we prefer having somebody tell us what to do? Don't teach me how to do it. Just tell me. What's the next step? Okay, what's this next step? It's easier, right? It's easier for us as an end user. Also, and this is the primary reason with respect to networking, things change in an environment. Not necessarily in a small environment, but in a large environment, like a large organization or the internet. That's a constantly changing environment. So you might make plans in the morning. Hey, let's go to Mod Pizza, or let's pick up a pizza from Mod Pizza tonight at 7 o'clock. Then something changes. Well, Mod Pizza has to close for whatever reason. COVID-19 got them. That's not true. They're still open, by the way. Well, they're one of my favorite pizza places, so keep going there. But that did happen not too long ago to me. We decided in the morning we're going to go to a certain restaurant, pick up some takeout to support them. We went there that evening. They had unfortunately gone out of business because of COVID-19. So now we have to figure out, well, where else are we going to go now? And we didn't have any good options at that time because it was too late. So we ended up going through the drive-thru at Whataburger, which some of you might argue is better or as good, but it's nowhere near as good. So yeah, speaking to Rahi and speaking to what some of you probably have in your mind, dynamic. You sacrifice speed or pre-knowledge for flexibility or somebody else doing something for you. And it's absolutely necessary on a large network or a large environment or the internet. You have to dynamically make it. Like when you're driving across town from one side of Houston to the other. We can't predict if there's going to be a car accident somewhere. But if there is, you better know some other detour or way to go, or you better be using a tool like Waze, which can say, oh, there's an accident 1 mile ahead, get off the freeway. I used Waze not too long ago, by the way, and I ignored it because I thought it was dumb. I thought it was telling me some stupid way. Like, why are you telling me to get off the freeway here and get right back on? So I ignored it, and I didn't get off the freeway, and then I got stuck in 30 minutes of traffic when I should have just gotten off the freeway. So I don't ignore Waze anymore. But it's not always right, but anyway. Ethernet. Remember who invented Ethernet? It's a data link protocol. And why don't we call it the DICSnet? DEC, Intel, and Xerox, because it's vulgar sounding, and we don't call it CM. Carrier sense multiple access with carrier access and collision detection, because it's too long. So Ethernet. The topology of Ethernet. Understand that Ethernet even today is still a bus topology logically, but physically it's laid out in a star. We lay out our LANs in star topology. Media access control is needed on LAN segment, not WANs, needed on a LAN segment because of the fact that everything can talk at one time. We need to control that layer 2 somehow. Know the difference between these different layer 2 protocols. What's a VLAN, a virtual LAN? Make sure you know what a VLAN is. You can have up to 4,096 VLANs. Why do I use a VLAN? Priority. Primarily to prioritize or separate traffic. We got one lane of a highway. maybe it's a wide lane of a highway, so we can say, okay, everybody with this kind of car get to the left and everybody with this other kind of car get to the right. We can do a little bit of control with a VLAN. What are some things to look at on a server for bottlenecks? The biggest bang for the buck, by the way, is always add RAM. RAM. Cheapest thing you can do, and the biggest bang for the buck is RAM. Spinning drives are slow and expensive. RAM has gotten a lot cheaper. If it's not RAM, it's increase the circuits. Either the speed of the circuits or the number of the circuits, or reduce demand. It's difficult to reduce demand. That's the thing that we have the least control of, is things that we can do to improve LAN performance is reduce demand, because we can't predict demand a lot of times. We can't control demand. We can control circuit speed. What is NAT, network address translation? Didn't go over it much in class, but make sure you understand generally what that means. When we, one of the extra credit assignments, or probably one of the lab assignments, is going to turn into set up a NAT router and set up a firewall on your computer. We can download NAT simulation software. I didn't mention this in class, but make sure you know the difference between a red network and a green network. It's not necessarily LAN and WAN, by the way. It refers more to public versus private networking with respect to NAT. There's a red and green network. There's also blue and orange, by the way, but I don't ask those questions. And no, it does not refer to the color of the cable. Already talked about that. What can we do to reduce network demand on a server? We can move static files closer to the user. We can add more servers. We can offload some of the traffic from one server to multiple servers. What does WLAN mean? That's wireless LAN. How are we doing on time? I'm gonna end a little bit early today, by the way, if y'all don't mind, so I can get these things published. Wireless LAN, WLAN, not wide area networking LAN, but wireless LAN. What are the advantages and disadvantages? Yes, there are many disadvantages to WLANs. Pros and cons to nearly everything. What are the primary disadvantages, by the way, of WLANs? Why would a company not want to have a wireless LAN?
Security issues.
Yep. If it's wireless, we cannot control where those radio waves go. So if it's a high security situation, we don't have wireless. Or if we do, we have really high in firewalls, or we mitigate things at the application layer. What are the different WLAN protocols, and which is the most currently used WLAN, like 802.11, 802.AC? What are the two common radio frequencies? Those are the physical layer protocols, 2.4, 5.0. What's the newest range? That's the new Wi-Fi 6. Very similar to 5G, by the way. Both of them actually use the new 60 gigahertz range, which also is what microwave ovens use. What's the difference in WLAN modes? Make sure you know the difference between a wireless gateway, like most of you have at home, versus an access point, simply called an AP, and a bridge, or a wireless bridge. You can operate most APs in what's called bridge mode for specific reasons. I'm not going to go into them right now, but go look in the notes for those things. Or better yet, you can actually find a lot of information on the internet about what's the difference. Just Google those three things together. What's the difference between those three items? They're very specific, different needs using wireless technology. That's basically, these two items are essentially tied together. What is WDS, a wireless distribution system? And why would I use one over just standard APs? Goes hand in hand with mesh networking. Now, I mentioned in WAN topology, a mesh network is desirable for redundancy, but we don't typically see mesh networking in LANs. However, in large WLAN environments, we do see, and we like to see, mesh networking. It's more expensive for a similar reason that it's more expensive in WANs, but It improves throughput, allows, and that's mostly because things are moving around, and radio waves are variable. The environment changes the speed. Somebody walks into a room and suddenly your networking speed is going to go down because of it, especially if they're large. What are the common ways to perform wireless security on a WLAN device? In other words, there's WP, WEP, WPA, MAC filtering. You need to know the difference between all of these. Or open, no networking. In other words, make it open and do it at the application layer with what's called a captured portal. I talked about that a little bit in class, but go Google for those things. There's more on the internet than there is in the notes about these items. And that's because a lot of this has changed recently. And there's also a lot of security issues. A lot of hackers are stealing people's data by setting up fake captured portals and calling themselves Xfinity Open Wi-Fi, for example, and they're really just sitting out in their car in front of your house, or sitting in an apartment next to you, stealing your data. In Chapter 8, like I said, there's not a lot of data points in Chapter 8, mostly because they're very redundant between Chapter 7 and Chapter 9. But basically, you need to know the difference between a backbone network and a LAN, those different layers. Access layer versus distribution layer versus core layer. Which one is physically closer to you and end user? Which one is physically furthest away? Core is typically the furthest away. Think of this, the way you can remember that is think of that a backbone network as the earth. The access layer is the crust of the earth, or the thing we're standing on. The distribution layer would be underneath that, or above, or the air, for example. The core is the core of the earth. That's very far away from us, and we don't normally want to go there as end users. We don't need to go there. Subnetting. Understand what that term means and why is it important for BNs or backbone networks. You're doing it in your subnetting assignment. Why are we subnetting? Why are we taking a large class B and breaking it into little pieces? For purposes of management, for routing, for reducing the traffic that's unnecessary going from point A to point Z, point A to point B, I should say. What's the difference between layer 2 and layer 3 switch? Make sure you know this term. What is an MDF, a main distribution facility? VLAN, how do VLANs interrelate with backbone networks? We use VLANs on backbone networks as well as LANs. What are disadvantages of using VLANs? What is a server rack cabinet? And I don't know if I asked specific questions on this test, I can't remember, but go ahead and look these things up anyway. What is a rack U? It's 1.75 inches high by 19 inches wide. It's what the base unit of all networking equipment is, commercial-based networking equipment, based on a specific chassis size. And that's because MDFs, and the reason it's related to that, main distribution facilities many times are generic. Didn't used to be generic. Some smart people, some engineers came up with some standards for physical sizes so that we could build racks and then build equipment that fits specifically into those racks from different manufacturers. So a rack U is that specific size. And it's not a different size in Europe. It's that. They measure it in millimeters, like 44 millimeters, but essentially it's the same thing. What's QoS? QoS, very similar and used hand in hand with LANs, with VLANs, excuse me. It is for traffic prioritization. Quality of service. We can tag packets, tag frames as special frames. This guy has a VIP pass. Let him in the door so he doesn't have to wait in line at the nightclub because he's important. That's kind of like what QoS is. It's a VIP pass. or packets and frames. It lets them in the door first because they're important. They need to be seen first. They need to be dealt with first. In chapter 9, make sure you know what a common carrier is, like AT&T or Comcast. You can go Google for that. What is a common carrier? Go ahead and look that up. I didn't talk much about DSL in the class. And it does exist still. It's a WAN protocol, which is still used, a WAN and a networking protocol, which is still used, but it's quickly being phased out for Metro Ethernet or DOCSIS. It's kind of taking the place of DSL, and that's because it's much faster, or just straight Ethernet, or MPLS, which is what AT&T uses on their fiber gigabit network. Make sure you can describe in a WAN, star topology, ring topology, mesh topology. What are the pros and cons of each of those? There's very good, fairly good slides on chapter 9. This should be very fresh in your mind because we just did chapter 9. Why you would choose one over the other? Usually it boils down to cost. What does that term mean? Point of presence, or POP. A common carrier must have a POP in your area in order to deliver services. Make sure you understand that term. I think I left that out of the notes. But make sure you know what last mile or local loop means with respect to a common carrier POP. All of those three items relate to each other specifically. A common carrier has a POP in a city, and the cable physically from your building to their building is called the last mile or the local loop. Who typically owns the physical topology of the WAN? And it is typically not the end user, it is the common carrier. That's why it's called a common carrier. Sometimes they're called utility carriers as well. The internet is a utility at this point. What are the different T carrier services like T1 and T3? Still being used, so you do need to know the speed. Like T1 is 1.54 megabit per second. T3 is 45 megabit per second. The fastest level of T3 is slower than the slowest level of OC1, which is 52 megabit per second. The fundamental difference between those two, that's fiber and that's copper, using the traditional old school telephone lines coming to you. Not the same thing as using a modem, just using the copper wire. It's copper versus using fiber. What is dedicated circuits versus shared circuits? I talked about that already. That's like you're renting a tollway from a company that built the tollway for you, and you get exclusive use of that tollway and nobody else can use it. Whereas a shared circuit is you're sharing, you're getting a tollway, you're getting to use that tollway, but you're sharing it with other companies that also paid to be on that tollway. The primary reason you use a shared or packet switch service is because it's cheaper. You have the potential of using the full bandwidth of that tollway when it's 3 in the morning, or we have a COVID virus going on. I was driving around, by the way, I know I get off topic a lot, but it helps you to remember these things. I was driving home last night. I had to go up to my data center in Sharpstown. And I was coming back home at about 11 at night. I did not see one single car driving 16 miles home from the co-location facility. Kind of scary. I did see one wrecker that was probably responding to an accident or something, but not one single car. A little scary, but it's not that infrastructure is when you have the full use of an infrastructure like that. And I was running red lights too because there's nobody around, so I'm running red lights. Can't do that in the daytime because I'll run into somebody. But that's what the analogy of that is. So a lot of companies choose to use a packet switch service because it's cheaper than having your own freeway. And if you choose to use that service when it's not very busy, like the middle of the night, you have the full use of that bandwidth. You can break the rules from time to time. What's the major difference between ATM? ATM is the protocol that's used on DSL, by the way. So you need to Google that up. DSL equals ATM protocol. DSL is to ATM, by the way, as cable internet is to DOCSIS. And Cat5 is to Ethernet 802.11. Okay, it is this is the layer 2 protocol being used. So ATM is what's being used on top of DSL. Only 53 byte frames. And that's because that's a very heavily shared network. I didn't talk about it much in class. You're not going to encounter DSL with ATM very often, but you do need to know it. So I ask possibly a question on the test. It all depends on the roll of the dice when you take the test as to whether you get that question or not. So look it up anyway. Where am I? What is a VPN, virtual private networks? I just talked about that, so make sure you Google up and study. And there's a lot about VPN on the internet. The difference between an infrastructure VPN and a road warrior or an end user VPN. Make sure you understand, not tunneling, excuse me, tunneling and encapsulation. Make sure you understand those terms. What is intranet versus extranet versus internet? Make sure you know the difference between all three of those. Dynamic routing versus static routing, which is faster. As I mentioned before, I was hyping up dynamic versus static. If you know the routes you're going to take, and there basically is there, if there is only one route, static routing is faster to get data from point A to point Z. But in a dynamic environment where there's multiple routes or situations change, one route goes down, you need to opt for dynamic routing. It's about a 3 to 5% hit or loss of maximum throughput of your data, but it's needed because at least on WANs, it's needed because you're typically and you're usually sharing. You're sharing that freeway. You're sharing that WAN with other companies. Very few companies have their own dedicated WAN services anymore. It's just too expensive. It doesn't have the flexibility. Also, going back to cost management, one of the most expensive things, and that's why I mentioned it, MRC, monthly recurring costs with respect to WAN dedicated services will kill a company. There are companies right now that are paying thousands of dollars a month for dedicated fiber services to their buildings to provide internet access, and their buildings are empty. They're paying $20,000 a month for fiber services, and all their employees are sitting at home on their $60 a month Comcast service or their AT&T service. But they can't get out of those contracts because dedicated circuit service contracts are typically 3 to 5 year contracts, and they will hold you to them. I'm fighting with Comcast right now on behalf of two of my clients actually to try to get them out of dedicated circuit contracts. They literally just signed a contract about 2 months ago. Because of the whole COVID-19 thing, they've realized we need to rethink how we're doing everything. So they totally redesigned how they do everything, but they're stuck with a $5,000 a month dedicated monthly recurring cost bill because they signed a contract. So got to be really, really careful with WAN dedicated services. Usually with packet switch services or using the internet and VPN, it's much cheaper services and it's much more dynamic. And if you don't like one company, you can fire them and use another company. It's usually month to month, or it's a short, or it's a small penalty to quit. AT&T's internet services are 30-day contracts. So when you're selecting WAN services, you need to consider the monthly recurring cost as well as how long it's going to take to install it. Security, speed, reliability, flexibility. That's pretty much it for the study guide and what you need to know to do well on exam 2. Like I have said before, the way I would study for this is, first of all, do your subnetting assignment. Turn the subnetting assignment in a few times until you get something above a 95% on it. It should grade it properly. You have until April 11th to get that assignment done. The exam 2, Saturday night, midnight, 3 hours. When you start taking it, you need to complete it. I think you can start it and stop it, but I wouldn't do that. I would try to set aside 3 hours. If you have a technical issue, because we're all at home having issues, of course, let me know. What else on that? Oh, like I said before, the best way to study for my test is copy and paste these data points into a new document and then answer each one of these questions in your own word. A POP is a local building where a provider or whatever. Type it in your own words. Several of you on exam 2, or excuse me, on exam 1, obviously just cut and pasted something you read off the internet, which either contradicted or was not quite what I was looking for in describing something. Now, the essay part of exam 2 is doing the subnetting assignment. So there are no real essay answers. But guys, you're not going to learn this stuff if you're just copying and pasting stuff off of the internet. You will end up getting a fairly good grade on your test because you're becoming a good Googler or you're becoming a good copier. But 6 months from now or a few months from now, you're working in a job and or maybe another situation like we have now comes along and your company relies on you. Okay, we got another Hurricane Harvey, for example. Somebody comes along and says, okay, what should we do here? What are the best practices? Should we go with dedicated land service, WAN service, or should we use VPN? If you don't know the answers and you don't know the best practices and the methodologies based on what you learned in class or what I'm trying to teach you in class, in my 30 or 40 years of experience in doing this stuff, and this is why I think I know a lot more than a lot of teachers, because I actually do this stuff, and I learned the hard way a lot of times what not to do. If you can't produce or you make a bad decision, you can cause your company to go out of business or spend a lot of money. They will fire you. They'll get rid of you. And MIS jobs are really good to have if you know your stuff, if you can deliver, if you have I've got a couple people in class that have been working in the industry already for a couple of years. Right now, you could probably get a very good job asking for $100,000 a year or more, as long as you've got a degree and as long as you can show them that you know your stuff and you got a couple of years experience. Because like I said, and I can't stress this enough, the second most expensive thing other than people for most companies is the MIS function. The S in MIS should be a dollar sign. And the MI should stand for like money is, or money incredible dollars. It's the salaries are high, the costs are high. I have a friend and she is one of the top MIS directors for Shell. She retired recently. Her most recent salary that she was receiving was $600,000 a year. She was in charge of a $14 billion budget. And that was only part of Shell services. Took her a while to get there, but she was an MIS manager. She was an MIS major, graduated from University of Houston. So if you would like to make $600,000 a year when you get ready to retire, don't just get the degree in this stuff, actually learn this stuff. Take the time to pay attention to what I'm talking to you about. Don't just copy and paste. I can't stress it enough, guys. And please disagree with me if you think that you've found something. I'm always learning, like I said earlier. The people that do well are the people that other people think they know everything they think they know nothing, or they're always questioning. I'm constantly questioning some of my best practices, sometimes to a fault, but I go back and I have to redesign and relearn things and new ways to do things over and over because of changes, not just changes in technology, but changes in environment. Like right now, what we're dealing with right now, this COVID virus thing and working from home. This is unfortunately become the norm. This is, somewhat of a blessing in disguise, actually. If you can look at the bright side of a lot of this, is it's essentially forced companies and forced end users to have to adopt these technologies that we've had for literally 25 or 30 years. I've been telecommuting for a long, long time and setting up remote telecommunications and telling people how it's so much cheaper, so much easier. If you got a problem, the most expensive thing you can do is get up out of your chair and leave your home. The cheapest thing you can do to fix a problem is open up a laptop, push a couple buttons, and fix things. Okay, so any questions about exam 2 or the rest of the semester or COVID-19 or jobs or what? Any questions? Or what's for dinner? I'm going to Mod Pizza, but I'm ordering online. No questions?
Nope. I think I'm good.
Okay. All right then, guys. So I will post this. I'm going to end this and I will post this meeting, which thank you guys for participating. Not everybody's participating in these. You guys are all the ones that make A's, I'm sure. The ones that quote unquote come to class, whether it's in person or online here. And you guys are the ones that will do well. So keep doing that. See you all on Wednesday. Same bat time, same bat channel.
See you Wednesday.
Thank you. Bye.
You're welcome. Thank you.